Hey, we're back for our last video lesson from stats class. So we're going to talk about the paired t-test. So far we've done the two sample t-test for z, or the two sample z t-test. We've done the two sample t test, and now we're going to do the paired t-test. So when you have a paired t-test, you tend to get raw data from this, and they always come in pairs. Things like husband and wife, twins, left versus right, but the most common one is before and after. And a lot of it's done in drug studies. So before they take the drug, they measure something, and after they take a drug, they would measure something. So this one is similar to that. Here's our formula for this. My notation is a little different from what the book has, but you can use your book or you can use my notes when you take the exam. So I'm neutral to that, which notation you use. They use a capital D for the X bar, but all the other books I've used in my life have an X bar subscript D. So the mean difference is what we're looking at. So we've got two groups. We had a before and we had an after. And when I subtract that, before minus after, like the first one, 243 minus 215 equals 28. Notice that difference is positive, right? So when I'm getting a positive difference, that actually means a decrease, right? This decreased, correct? And the answer came out positive. This decreased, it came out positive. This decreased, it came out positive. In fact, they all came out positive, all right? So keep that in mind. Now, if I would have had after minus before, they all would have been negative, and our test would have been the other direction, but the answer would have been the same. So let's keep that in mind. All right, so here's what our problem says. A medical researcher wishes to see if he can lower the cholesterol levels through diet in 6 people by showing a film about the effects of high cholesterol levels. The data are shown. So I have that as a table going vertically this time. At alpha equals 0.05, so that means the right 5% in this case. Did the cholesterol level decrease on average? All right. So decrease in this case, when we did our differences, was a positive number. All right. So decrease on average was, is it a big number? All right. Is it a big positive number? Far enough away from 0. So I set this up as mu d is the mean difference in cholesterol from before to after. All right. And again, that would be a positive number. And our null hypothesis is mu d equals 0, as it always is, the equals there. So 0 means no difference. And then our alternate H1 is mu d is greater than 0, right? And those are all greater than 0, so there is a difference. So we have our 4 assumptions. X bar d is from a simple random sample. Our samples are paired. That's a new one, and they were paired here. We had 6 pairs, so n is 6. The distribution of differences is approximately normal. That's truly an assumption. We're just going to assume that's happening. And the last one is sigma d is unknown, which is why we use a t-test. When you don't know sigma, we use a t-test. Now, how do I get these values for x bar d and sd? That means the standard deviation of the differences. I had to take this data set, just this last column, just the last column. That's all we care about now. So everything else is not important. This is not important. We got our list of differences, those positive differences. And remember back in chapter 3 or 4, we did mean and standard deviation. So I figured that out. And you can see my calculations on your worksheet. All right, so a little review on that. My x bar d was 15.5, so that was the average difference, right, from before to after. That was a positive difference. And my standard deviation came out to 10.616. All right, that's the average distance it is from the mean. In this case, n is 6. All right, so keep that in mind. All right, now we got to our critical value. So I went to my table and I went to one-tailed, right, because it's not a not equal sign. It's just a greater than sign. And I got a critical value when I had a degree of freedom of 5. Because I have 6 values, minus 1 is 5. So I looked on my chart for one-tailed at 0.05, and I went over to the row that says 5, and I found a value of 2.015. So that's our divider between don't reject and reject. So this number is far enough out there, we're going to reject. So I plugged my values in step 4, and I got 15.5, which we calculated earlier, minus 0, which is the hypothesized, right? So in my formula it says, what's mu d? Well, up here we said mu d equals 0. So I put a 0 in that spot. my standard deviation divided by radical 6. All right, and I got 3.576 as our answer. So that's going to be to the right of our critical value, right, which means they're going to reject. So reject the null hypothesis. There is significant evidence to suggest a decrease, right? When you have a large positive number, that means decrease in mean cholesterol level. All right, so the trickiest part to this problem is coming up with the idea that when I subtract and get a positive number, that was a decrease, right? What if we had the opposite and we had the number 8 and then the number 10? Well, 8 minus 10 is negative 2. So an increase came out as a negative, all right? So then the other tough part is the word decrease in this case was positive, so I had to have it as greater than 0. Positives are greater than 0, all right? So that's the toughest part. Everything else is pretty easy. It's a simpler hypothesis test. You'll probably see one in your exam, all right, with a small data set. But keep my notes handy, model how I do it, and you should be fine. All right, so that's my last video presentation. I have no jokes for you. No, not a one, all right? It was great having you this semester for the 7 or 8 weeks that we were together. Hopefully I'll see you around campus next year. Bye.